Welcome to the Australian Defence Force online training series, Introduction to Satellite Communications. This video will introduce the main concepts of satellite communications, otherwise known as SATCOM. We will describe at a high level what SATCOM is, the four main segments of SATCOM, take a high-level look at environments which form together to enable satellite communications, the services that are supported via SATCOM, and then finish with an example scenario to demonstrate how SATCOM could support deployed defense personnel. What is SATCOM? Something you may not know is that there are tens of thousands of commercial and military satellites that are tens of thousands of kilometers orbiting above the Earth, each capable of providing and supporting a variety of functions. We are going to help you understand a little more about what those functions are and their purpose for the Australian Defence Force. SATCOM systems require the use of satellites positioned in space to enable voice and data telecommunications from one part of the world to another. But there is more to SATCOM than simply pointing a stick in the direction of the sky, hoping it will find the satellite in orbit, and then reach the intended recipients on the other side of the globe. The complete picture includes four main elements that you can see here. Each are vital for ensuring defense's SATCOM capability. To gain a better understanding of SATCOM in its entirety, we need to understand a bit about each of the elements in a little more detail: space, ground, terminals, and control. The first area we will briefly touch on is space. Thousands of kilometers above the Earth, satellites are positioned to help bridge the Australian Defence Force's beyond line-of-sight communication gaps. When we look at the space element, we are primarily concerned with the capability of the particular satellite or spacecraft's ability to support the necessary operational requirements and more when the need arises. The element we are particularly interested in is the hardware that is fused together to provide the capability. That fused hardware is known as the payload. The payload is essentially the combined configuration of attached transmit and receive capable antennas, of which there may be multiple, and the internal electronics that pass signals around inside the spacecraft. Because some of these spacecraft are in orbit as far as 40,000 kilometers above the Earth, the electronics on board need to amplify the received signals with enough power to reach the required destinations. Satellites that are selected to fulfill tasking as the conduit for receipt and retransmission of received data and media are often referred to as a bent pipe. This term comes from the order in which signals are received and then retransmitted. Shown here in our simple diagram of data transmissions, after receipt of the signal, the uplink signal is then amplified, translated to a downlink signal, re-amplified, and directed back to Earth via high-gain antennas. It flows in a similar fashion to that of a bent pipe in space. Next, we will take a look at the ground element. When we talk about ground in SATCOM, we refer to anchor stations. So what are anchor stations and what is their purpose? When we hear the word anchor, we often associate it to something that we drop in the ocean floor to help assist with keeping a ship or boat stationary. Anchor stations effectively handle many types of communication traffic that is essential to day-to-day business for our deployed assets and personnel to operate and achieve tasking effectively. In addition, anchor stations also provide local loopback facilities to permit communications between smaller SATCOM terminals, which would not be possible due to power constraints. The stations also provide patching and switching connections to a variety of defense terrestrial networks via cable, fiber optic, and microwave links, or laid infrastructure to funnel data and information across a variety of networks vital to defense's daily operations. Now we shall take a look at terminals. There are many types of terminals that are in use across the services to support the many and varying platforms and environments requirements. For each environment and the capability of each platform, we need to take into account size of the platform or asset and the requirement to get communications to it. Not all SATCOM terminals are the same. Again, factor the requirements for some platforms to stay mobile or even be inconspicuous pending the environment it's tasking may take place within and limitations on the size of certain hardware that it can carry. Which now brings us to gaining a further insight into how SATCOM-supported communications works to assist defense. As just mentioned, due to the size of certain platforms, there may be restrictions to the SATCOM hardware platforms may be capable of carrying and supporting. For example, the size of both the transmit and receive antennas will vary depending on the platform they are fitted to, and the available space that platform has available to fit hardware within or on. For instance, an aircraft such as an AP-3C Orion compared to a Canberra-class landing helo dock. To help with our analogy, the mouth and ears shown here become the various assets that may be deployed around the globe. The transmit antenna being the mouth and the receive antenna is the ear. A large mouth, or a powerful transmitter, will be able to transmit a signal powerful enough to be re-amplified by the orbiting satellite and heard by the smallest of ears back on the ground. The set of ears on the satellite also have to be pretty big and finely tuned to ensure it hears even the tiniest of whispers, as that whisper may contain vital information. Then pass that information to wherever it needs to go with sufficient power. However, a small whisper may not be re-amplified by the satellite with enough power, since power on the satellite is finite and needs to be shared amongst all signals. Subsequently, due to lower re-amplification, smaller ears on the ground may not be sensitive enough to receive the transmission. Further, in order for users requiring information to be sent and received, they must ensure they have compatible waveforms or modems, the right settings, and crypto loaded. Otherwise, it would be like transmitting or receiving a foreign language, or not receiving anything at all. Now we will take a look at the final element, control. Control for defense is coordinated through the Defense Network Operations Center, or DNOC as it is commonly referred to. The DNOC is located in the ACT at HMAS Harmon, Canberra. The DNOC is the hub of the third largest communications network in Australia, after Telstra and Optus, which provides network support for just about all military operations. As previously mentioned at the beginning of this video, it is essential to defense SATCOM capability that each of the four elements be fully operable to support the capability. Each element is vital to enable communications between defense assets globally. As seen here, if any element is broken, not operating efficiently, or removed entirely, defense's SATCOM capability will effectively cease. Now let's take a look at some of the services that SATCOM supports. Starting with narrowband supported operations, narrowband effectively provides communications support for systems that only have small bandwidth requirements. For example, voice, inclusive of phone and radio, while chat and fax are some other examples of narrowband communications types that may potentially require support. The data throughput of narrowband can be, for ease of understanding, be thought of as a regular garden hose, maneuverable enough and provides enough output to fulfill jobs that require doing. Now let's take a look at wideband communications. Video, bulk data transmissions, internet, all supported ICT networks like the Defense Restricted and Secret networks, plus other required networks that can be supported through wideband operations. This includes everything that we mentioned in narrowband, voice, chat, and fax, etc. Taking our regular garden hose analogy, wideband could be thought of as that fire hose. a lot more data throughput, greater water coverage, and capability than our garden hose. Well, why not use wideband everywhere? Narrowband SATCOM provides beyond line-of-sight capability without the need for complicated ground terminals and precise antenna pointing. Narrowband terminals allow operations to be highly mobile, lending themselves to use in field situations, providing a more robust solution for tactical operations. To demonstrate how Defense's SATCOM capability can be utilized around the globe, the following scenario will provide a probable situation requiring the use of both narrowband and wideband SATCOM to bring health and well-being to one of our deployed assets supporting operations. An asset deployed on operation has scheduled a barbecue whilst opportunity exists, to provide relief and some much-needed time out from operations and to maintain good morale by showing the Australian Rules Grand Final. The live stream of the Grand Final was requested and programmed for streaming by the unit through the Defence Network Operations Centre, who coordinate the live feed to be distributed using available Defence wideband capability. Through an unknown technical glitch unbeknown to DNOC, the live feed has dropped and is no longer being transmitted to the deployed unit. With everyone in full swing supporting the two teams and enjoying the much-needed time out from the grind of day-to-day operations, the loss of signal instantly puts a damper on the barbecue and the festivities. Realizing the mood is quickly souring across the crew, the barbecue chef quickly reacts, pulling out the SAT phone to call back to DNOC to let them know of the immediate problem now being experienced on board the deployed unit. The SAT phone, operating via UHF, is able to use similar infrastructure via the same path to reach the DNOC and get the message through of the dropped live feed. The DNOC on watch team quickly reacts, reinitiating the wideband live feed back to the unit. With the signal reinitiated by DNOC, cheers of happiness, dancing and laughter can be heard as far as New Zealand and Hawaii, as the crew once again gets into the swing of taking time out to celebrate achievements from their operation, whilst enjoying one of Australia's great sporting moments. That concludes this video on Intro to SATCOM. We hope this video has helped you understand a little of SATCOM in defense, clarify any misunderstandings you may have surrounding SATCOM, and the way in which it helps keep defense connected.